Elements of Photogrammetry, Lecture 5, Image Measurement and Refinement. As we move ahead in photogrammetry, starting to get more into the technical end of things, understanding how things are done, the kind of precisions that we can expect, we need to understand first and foremost that all photogrammetry is going to come down to measurement in an image coordinate system. We're going to talk about a lot of different principles, a lot of different equipment, a lot of different ways of doing things, products, and procedures. But it all is going to come back to an image coordinate system. Everything that we're going to do is based on that image coordinates. The refinements that we're going to do, any corrections that are made, measurements, whether they're on individual photos or in stereo pairs. Stereo pairs being those overlapping photographs where the same object is imaged two times and you see things in 3D. It's all based on the coordinate system. Later that we're going to see that there are mathematical and mechanical and digital methods for extracting those values, but they all are going to come back to the same basic principles. Even going back to that idea of that Da Vinci, that quote that we had about the pyramidal effect of perspective, and those early mathematicians who explored the math of that perspective, explored the math of where things appeared in photographs. All of that comes down to measurements that are made in some kind of a coordinate system. Now, a lot of this that we will be looking at, in one sense, it isn't day to day, the day to day kind of things. I don't sit there and determine individual measurements within a photograph um, for everything that I measure. But every single reading that I make, if I'm collecting a map on any given day, I may make several thousand recordings per hour, however many in a shift. Every single reading is going to come down to that coordinate system. The instrumentation is going to take care of the measurements for me. So since everything is based on that, everything comes back to this coordinate system, it's really important to get a feel for the theory, a feel for the importance placed on the precision and the accuracy of and error removal. As you look at this slide, the idea here is that in photogrammetry, the origin is placed at the center of the photo. The center of the photo is determined by the intersection of the side fiducials. Now there are 8 fiducials, and there are 4 on the sides and 4 on the corners, and those are all going to go into adding accuracy in determining the transformation between this photo coordinate system and any kind of instrument coordinate system. But by practice, what we call the principal point, the center of the photo, the place where a light ray comes through the direct center of the lens, perpendicular to the film, strikes the film. That is the intersection of the 4 fiducials on the sides. So that is going to be our 0, 0. Now, later we're going to talk about kind of a theoretical principle point where that actual perpendicular would strike. Our measurements are going to be based on the intersection of these fiducials. The optics would determine that a light ray coming in perpendicular to the film plane may or may not strike it right at that 0, 0. It may strike it a little bit off. We'll talk about that later. But for purposes of measurement, especially any kind of measurement that we're going to be doing, we're going to consider the intersection of these two, photogrammetrically, this is called the principal point. By convention, positive x is assigned to the direction of flight. After that, it's just a normal coordinate system. Typically, we're going to be measuring in millimeters. Those side fiducials are somewhere in the neighborhood of probably about 110 millimeters from the center. So it gives you some idea how big that is. But after that, from that 0, 0, you can measure points in there, and anything that applies to any coordinate system applies to this image coordinate system, whether it's transformations or measurements or using the distance formula or angles from the different axes. All of those things are going to apply to this coordinate system. Now, as far as measuring points in that photo, we're going to look at a few different methods. The first method, and certainly the simplest, would just be to grab a ruler or a scale and just start measuring values. My very first photogrammetry class, the very first lab, the first thing that we did was take a steel straight edge and a needle point and strike just a tiny line across the paper photograph, hooking up those four fiducials, finding the 0, 0 in the middle, and then grabbing a scale and just measuring the coordinates of different points on a photo. Anything marked like this, any measurements taken based on these markings, you can be as careful as you want. They're only going to be within certain tolerances to begin with. I mean, of all the things that we're going to use for measurement, this is obviously the least accurate, but it gives you an idea of just exactly how these photos work. If we're looking at the distance, we've got the coordinates. We've got a x and a y for B, and x and a y for A. Certainly we can do the deltas, get the difference in those coordinates, and then use that to compute a distance based on those coordinates. Now, the next method we want to look at is this is non-destructive, where we don't have the principal point marked and we can't mark it. The rest of this video, before we take a break, is just going to be explaining this, because we are actually going to do this on a digital image. So this is one of those where I'm just going to explain what's going on, and what you'll want to do is follow closely and come back and refer to this if we need to. The point of interest, all right, P, is a point that we want to measure. Now the way I've got this labeled is we've got four fiducials. Fiducial 1 is on the left hand side, fiducial 2 is at the bottom, fiducial 3 is on the right, fiducial 4 is at the top. Those are labeled as line segments. 1, 2 is the line between 1 and 2. If we have coordinates for those 2 points, which we will from our camera calibration, you can compute the distance between those points. The distance from point P to fiducial 1 is line segment P1. From P to 2 is line segment P2. If we are dealing with fiducial 1, fiducial 2, we've got some angles that we'll want to measure. The A angles are always going to relate to the angle from the axis to the line connecting the fiducials. That's always going to be A. So we can actually look at this from several different ways. You can see 1A, 3A, or 4A, always talking about the angle from the axis to the line to the fiducials. B is always going to be from 1A, or from the A angle that we can calculate. The angle B is another one that we're going to be able to calculate, and then we can take A minus B and compute C. Well, the way we're going to do that, okay, and let's go ahead, look at the line segment from the origin to 1. All right, that is a distance. The origin to 2, that line segment, that is a distance. If we want to compute angle A, we take the opposite, origin to 2, it's a distance we can calculate, origin to 1, okay, O1 over O2, opposite over adjacent, inverse tangent or arctangent, and that is going to give us 1A. So all those numbers are given. The coordinate of 2, the coordinate of 1, those line segment distances can be calculated. Using those line segment distances, opposite over adjacent, we can calculate 1A. So we already have line segment 1, 2, because we can calculate that from the coordinates that'll be given. We've got angle 1A. All right. Next, we can use a measuring tool and measure distance P1 and distance P2. Those are just numbers that we can use one of the measure tools in image processing software, measure that in millimeters. So we compute line segment 1, 2, we measure line segment P to 1, we measure line segment P to 2. Then, using all those numbers, there is the law of cosines, and that's, this is just something that all you have to do is plug in the distance P to 1 that we measured squared plus the distance 1 to 2 that we computed using the distance formula squared minus the distance of line segment P to 2 that we measured squared. So P1 plus 1, 2 plus P2 or minus P2 divided by 2 times the distance from P to 1 measured, the distance from 1 to 2 computed, 2 times this times this. Right. Divide the first number by that number. That's just going to give us a number. We take the arc cosine or the inverse cosine, and that gives us B. So we computed A, we just computed B, if we take A minus B, we get C. So now we have the angle. We just computed the angle from the axis to this line that we measured. So 1C equals 1A minus 1B. What we have now is a triangle. We have the angle, we have the hypotenuse, which we measured. So to compute the x, we take the cosine of the angle. Right? We computed the angle, just punch in the cosine of that angle times the hypotenuse gives us the total x distance. But remember, the x coordinate is starting from the origin. So if this is, for example, 110 to the negative, and the adjacent side is 125, we've got negative 110 plus 125, so the x coordinate is 15. In this case, the y coordinate is going to be the opposite sine, this angle, opposite over adjacent. So we take the sine of 1c times the hypotenuse is going to give us the y, because we can look at it and see that it's below the origin. We're going to say that's a negative y. It wouldn't be that hard to write a program to figure out what quadrant things are in, but what we're going to do on this is just visually look at it we're going to compute one of these, and when we compute it, just visually look at it and say it makes sense that it's a positive x. It makes sense that it's a negative y, because that angle, that c, if we had a point up here, it would be the exact same math, but the y would be positive. If we were computing a point back here, the math would all basically be the same. It would be a certain distance from number 1, right? But if it's, the distance from 1 is 75 and 1 is at negative 110, then it makes sense that it's a negative x, 110 minus 75, that x is negative. So we'll take a break here and leave this at a place where you can come back and find it easily.